Okay, my name is Paul Weaver from National Physical Laboratory in the UK, and today's workshop is all about measurement of piezoelectric properties at elevated temperatures. So I'll do a short overview of the talks that we'll be going through today. So we'll be talking about high temperature piezoelectrics. I'll give a brief overview of some of the industry applications, some of the areas of interest and why we're interested in this. I'll very briefly in this introduction describe some of the work that we're doing to interface with development of new high temperature piezoelectric materials, some of the metrology challenges, and an introduction to the METCO project. METCO is a metrology project that we've set up to investigate the metrology of high temperature piezoelectric materials. Okay, so why are we interested in this? There's at the moment for any piezoelectric activity really that requires power, so anything that you need to deliver power, if it's an ultrasonic technique, for instance, or an actuator, and to a certain degree sensors and transducers, then the materials like PZT, for instance, they have a transition temperature, Curie temperature of around 350 degrees Celsius, and they're only really effective up to maybe around 200 degrees, and then you start to run into problems. Now, there are a whole lot of applications that would be enabled if we could have materials that would operate at higher temperatures. So that's one aspect of it. And also, even with materials like PZT, they're operating at temperatures of around 200 degrees or even higher. There are still challenges associated with being able to do that. So some things that we could do if we could operate at higher temperatures, there's lots of interest in power and process industries for non-destructive evaluation. So this is ultrasonic techniques, and being able to put transducers for monitoring the structural integrity of steam pipes, for instance, would be a big advantage in power and process plants. Valves and transducers for cars and air engines. So this is fuel control. Of course, the piezoelectric diesel injector valve has been around for a little while now, and but there's also interest in being able to do the same thing, deploy piezoelectrics in aero engines for final control of the fuel flow, and a range of other actuator and valve control applications in aerospace. Then there are applications like ultrasonic surveying, so this is oil and gas industries, downhole surveying, where as we're moving to deeper and deeper reserves, then the environment is getting hotter and hotter, and piezoelectrics are widely used for ultrasonic surveying downhole. And even things like medical ultrasound, where you wouldn't think the actual operating temperatures would be very high, but there is an issue around high temperature sterilisation and the stability of the transducer when you sterilise it. Okay, so some of the metrology challenges, they reflect in many ways the technology challenges. So the kind of things we're interested in are actuators, sensors and transducers, and some of the things which we need to understand to engineer devices are things like field and frequency effects on piezoelectric properties at elevated temperatures. Thermal expansion is an important aspect and is often overlooked. If you think of something like a valve operated by a piezoelectric material, it needs to operate between an on position and an off position. And if your piezoelectric activity is up here or down here, the valve won't open and close effectively, no matter how large the actual piezoelectric displacement is. So that offset, that thermal offset, and the coupling between the thermal expansion and the piezoelectric properties are important for those types of applications. things like aging and stability in piezoelectric properties. And I'm talking here not just about low field properties, but also the effect of time on the high field properties when we start putting high fields on these materials. And related to that, of course, is power dissipation and losses. As things get hotter, it's a basic fact of nature that these materials start to become more conductive, and losses, particularly conductive losses, start to increase. And electrodes and interfaces effects, getting effective electrodes and electrical connections at high temperatures is challenging. And in order to understand these effects and to make progress in the application of piezoelectric materials to some of these devices, then we need to be able to measure the properties of piezoelectric. We need reliable, validated measurement techniques, and so that we can put confidence in some levels of certainty or uncertainty in the measurements that we're taking, and we can understand how one type of measurement, for instance a resonance measurement, might relate to an interferometer measurement of piezoelectric activity. So that's essentially the metrology challenge that we're trying to address in this project. Okay, this is the consortium of the project. The project is funded by the European Metrology Research Programme, and we're working with the equivalents of MPL. MPL is in the UK the National Metrology Lab, and there are equivalent organisations in most countries within Europe. So we're working with PTD in Germany, CMI in the Czech Republic, METCO in Finland, and LNE in France. We're also working with Exact Systems, who are partnering in the project, and with the University of Leeds and Cranfield. I would say that there is another aspect of the project. We're also looking at electrocaloric effects, and that ties in with the thermal effects on piezoelectric properties, but we won't be discussing that in the workshop today. Okay, so just briefly, I won't go into this in detail because Tim Stevenson will present this material later on today. But one of the things that we're doing within the project is we're working with Leeds University, who are developing materials to supply to the project. And what we're trying to do is to make sure that we are focusing the project on current industrial needs, but also to provide metrology into the research process so that we can support the development of new materials as well. And we'll see a lot more of this later during the talks, but some of the measurement techniques that we will be discussing are piezoelectric resonance measurements. We've got a number of different interferometry techniques that we're working on, and of course all of these over a range of different temperature ranges. Okay, so just a quick outline of today's talk. I'll shut up for a little while in a minute, and then Tim Stevenson will present some of his work on high temperature piezoelectric materials. Tim has been on barista training, so somehow he's got roped into the coffee break, but I think that's a copy and paste error. And then I'll give a presentation on the work we're doing on high temperature resonance measurements. Peter Williams unfortunately can't make it today, so I will give his presentation on the jamming interferometer that we're developing at MPL. Guido Bartel from PTB will then give a talk on the full field precision interferometry at PTB. We'll have a break for lunch, and then we've got a couple of industry-related talks here, which is very nice to have that industrial perspective, very important for the project. So Torsten Spitz-Kempen from Exact will give a presentation on the work that they're doing to extend the temperature range of commercial equipment for doing piezoelectric measurements. And then I'll try and pull all of this together and illustrate some of the comparisons, some of the relationships between the different measurement techniques that we're seeing. Some of these are still in the initial stages where we're starting to get data in now, and we're starting to run more formal comparisons between the different measurement techniques. And I'll describe where we're up to with that. And then after the coffee break, Tajik Roger from Joe Stefan will give us a presentation on some of the work that they are doing on high temperature bismuth-based piezoelectrics, and also ionics technologies. Tim Comyn will give a talk on some of the challenges surrounding commercialisation of high temperature piezoelectric materials. And that will conclude the day. Okay, so I'll show this slide again towards the end, but we have a project website which will be interesting if you'd like to have a look at that. You can contact us at that metco@mpl.co.uk. And I'd also like to thank the speakers, of course, for spending their time to put together the presentations and come here on weekends. All of you for simply giving your time to attend, and particularly I'd like to thank Tina and Barbara from JSI, who've been tremendous help in organising this workshop, and the Piezo Institute as well, and of course support from the EMRP, and thank you as well to Lydia for helping with the organisation at MPL and the final arrangements.